I didn't have the microphone on. The microphone wasn't on. Can you hear me now, Mauro? That's really, really embarrassing. Might edit that out of the live stream or just leave it in. Just leave it in. All right. I'm going to start over. So in last week's live stream, I explained about how when I learned some newer DevOps practices, I decided to redo the way I manage my Windows desktop. And I used Chocolatey Package Manager to control the installation and upgrade and patching of all my desktop software. And I stopped installing stuff manually. But I also was doing a bunch of projects where I would write some Python code or some scripts to do analysis of some data. And I was running into a problem where my Windows desktop was getting really cluttered with development tools, and they all had conflicting versions. I needed multiple versions of Python, and every project I did needed different libraries, and they all had different versions, and it was in conflicting. And I thought, well, I need to go a step further. And from now on, I'm not going to have development tools running on my Windows PC. It's all going to be in Docker. And I was doing one project where I wanted to fetch all of the email DNS records, so SPF, DMARC, and DKIM for the top 1 million domains, and then study them and look for anomalies and errors. And I thought, oh, you know what I really want to do here is I want to put my little scripts for this in a GitHub repository. And anytime I update them, what I want to see is I just run one command on my PC and it updates my Docker container for the project, gets the latest code from GitHub, and then runs my analysis and leaves the data files right there on my PC. And that's where my idea of running a little one-line project with Docker and GitHub started. And at first, it seemed like a really big idea, and it was complicated. That's because all of these things were new to me in a practical or operational sense. And over the space of weeks, it turned out this is actually not a big deal. It's really easy, and it's not a bad use case. For me, it was completely optional because my scripts are for this particular project are really small, and I could have simply updated the Docker locally and run it locally, and it wouldn't have mattered. I could have treated the Docker container like it was a virtual machine and logged in with Bash, updated my scripts, and it would have been fine. But I really wanted to learn a little bit more. And that's what tonight's live stream is about, is just sharing these small Docker lessons, because I know most of my friends are just getting started with this sort of Docker thing too. So what I'm going to do is I'm going to back up to the beginning. I'm going to talk a little bit about Docker. I'm not going to go super deep into it, but enough that you can follow along. Then I'm going to show you the specific features that were relevant to me being able to create a container that when it's built, clones a GitHub repository and then runs the analysis. So let me start off with giving you a tour of this GitHub repository. So here's my really very lame GitHub repository. And this project that I have that analyzes DMARC. And so rather than just building this into my own custom Docker container, I put this in GitHub. And so here's this file that contains all the domain names I want to do analysis on. In theory, this would be the top 1 million domains. Right now, I've just got a placeholder file with one domain in it. Right below it, gather.sh. This is the script that does the actual analysis. and it has some dependencies. It needs a Python 3 environment, a fairly up-to-date one, and it needs this program called check-dmark, and that itself needs a number of Python libraries. So there's a whole bunch of things that have to be built in. And when I was fiddling around with this just in an Ubuntu machine, it turns out that I had to keep everything up to date. And so one of my first tasks was, well, let's make a Docker container that's capable of running this silly little script. This little script, though, as small as it is, this was like literally meant to gather DNS data on 1 million domains. So this thing is going to run for days, if not weeks. And this isn't actually the full version of my script. I had this thing running many, many months ago before I Docker containerized it. And I let it run for weeks and gathered maybe 1/10 of the domains. And then I misplaced the file when I rebuilt my PC when I was reinstalling with Chocolatey. So I'm back to scratch. Anyways, so my first goal, once I have this script, is to create a Docker container that's capable of running this simple bash script, which will run this Python script. Now let me explain a little bit about building Docker containers. So what you're seeing on the screen right now is my Dockerfile. So the first thing you need to know about Docker is, for our purposes, Docker containers are Linux. And they're not virtual machines exactly. They're going to run in a really stripped down environment that has the minimum of what's needed to run. Now, when you interact with it, when you interact with a running container, it might actually look like a full-blown Linux OS. For instance, you can run an Ubuntu container and you'll see all of the programs that you see in Ubuntu. You could also install a different type of container that has just the slimmest part of the OS files and nothing else. And the idea is that what you want to do is take the application, just the core components, the minimum requirements that will allow your application to run reliably, and package that up into the container. And then all of your containers run in a shared environment. You want to re-envision your application not as a single server running many, many programs, but a series of containers which all might interact to create your application or the services they provide. I'm not getting so fancy. I'm really treating this as a small virtual machine, but with just what I need. And so when you want to build a new Docker container from scratch, you write a file called Dockerfile. And then there's a special specification language for saying, well, what do you want to include in this Dockerfile? And there's very few commands. And you'll see here, they're in orange: from, run, environment. And let me explain what this does. So the first thing I have is I'm going to say, well, what do I want to base my Docker image on? And I'm going to actually say, well, we're not building it from scratch here. We're actually going to base it on an existing image for Python 3. So someone else has actually created a Docker image that contains a very stripped down environment that's just enough to run Python 3. And that's really good. And I think it's a Debian or an Ubuntu-based image because it has apt in it. The next thing I do is I label it and say, hey, here's the maintainer, Michael, the cybersecurity librarian. Now, everything that you're going to see in this file at the beginning are instructions for building a Docker image, not actually running a Docker container. So this is like compiling it. And so the first thing I say is start with this Python 3 image, then let's update it. And it turns out that when I was experimenting, unless I upgraded it, my scripts didn't always run. And then the next thing I say is, let's install OpenSSH client in Git. Now this is going to be used later for cloning my GitHub repository. We need Git to do that. And if we want to clone a private repository, we need the OpenSSH client. Then the really important part, I want to install this Python package called checkdmark. That's the guts of what I'm doing, fetching all these DNS records. Someone already wrote the software for me. And I use Python's pip program to install that. And that one command does a lot. There's a lot of dependencies that get installed. And that's why I need to do an apt update first so that this will succeed nicely. Then I do something that's only there for me to clone the GitHub repository. You don't need to necessarily understand what this does, but I say, look, now what I want you to do is go to GitHub, fetch their SSH keys, and trust them. Okay. And then this next step says, let's go and clone this repository and build it in as part of my Docker image. So I started off with a plain old Docker container that has Python in it, and I updated that, and I installed a few extra packages that aren't there by default, and then I installed this special piece of software, and that was the base of my Docker image. But now I need to put in my script, and so whenever I build or rebuild this Docker image, it's going to go off and get my repository. Now I could, if you're familiar with GitHub, could do this differently. I could just say, and this is probably the command you would use for any public repository, git clone, and then the address to the repository. And that'll work just fine. But if you want to do this with a private repository, and this is the thing that got me confused, it's actually quite cool, is you're going to need some sort of authentication mechanism. Now here's the thing. I'm going to authenticate with my SSH keys that I've registered to my GitHub account. Well, I don't want to put those in my image. Those are secret. It turns out that there's an experimental feature in Docker that when you build an image, you can say, provide some secrets from the local environment where I'm running it at build time. And in this case, I'm going to say, you know what? At build time, let the Docker build process use my SSH key. This does not store my SSH key in the image. So I could distribute the image. No one else has access to it. It's just at build time when it wants to clone this repository and put the contents of it in this image. It's going to use the SSH key in the Windows session I've got going. And I'll show you a little bit about that. This is part of something that's called Build Kit. And it is an experimental feature. It's been around for a couple major releases. It's really cool. In order to make it work, I do need this line at the top that says syntax equals Docker, Dockerfile 1.0 experimental. If you don't do that, then as soon as you specify this, it says, I don't even know what that means, and your build process for your image fails. Now, here's what I started to think I had to do but didn't want to do. This Docker command called add at build time will take a file from the machine that you're building the image on and move it into the Docker container. And I've seen way too many people on Server Fault and Stack Exchange tell people to do this. This is on the news, on the cybersecurity news all the time. There are people that troll through GitHub and troll through Docker Hub looking for images that people have accidentally put their private key into. And if you happen to build an image and then you publish it and you've copied your key in, that's bad. So I don't want to say, oh, go and grab my private key and then put it into the image. Don't want to do that. This image was staying private to my machine. Maybe I could justify it, but I'd rather use this new method, which says, hey, when you're building it, give the build process access to the local SSH key, but only while you're building it, and don't copy it. There is another thing I could do at build time, and that's that I could say, you know what? Maybe what I'm going to do is mount, every time I run this container, I'm going to mount my C drive on my Windows machine. And I'm going to mount it as a folder called data. And then what I'm going to do is say, whenever I run git, what I really mean is use this identity for SSH. And I'm going to come back to this at the end. This is a cool way that I could safely say, when I'm running the Docker container, not when I'm building it, let it have access to my key so that I can push data back up into my GitHub. So the final thing in my Dockerfile is, after this is all this stuff up until now is building the image. And then you can run it as many times as you want. But the final step is to say, whenever it's run this script. Now this just happens to be the script that I got on my GitHub. That's the goal of this thing. So all these commands would say, build up an image. Part of the build process is start with a Python 3 image, install all the dependencies, clone my GitHub repository. Now I built the image. Now whenever it's run that script that we cloned. And then what's going to happen when I run this thing is it's going to run it. And, you know, if I've got a million domains, it's going to run for weeks and weeks and weeks. And then it's going to exit as soon as it's done, which is really cool because I don't have to maintain it like a VM. Let me show you how this works in practice. So here we are on the command line in a PowerShell window. Not going to be doing any fancy PowerShell here. And what we've got is in this directory is that Docker file we just edited. Now I have two things I have to do. So I lied to you with the clickbait in my live stream title. I said one-line projects. It's actually two. Could do it in one line if I wanted. I have to build the Docker container, or sorry, the Docker image. Once it's built, I have to run it. So here's what we're going to do to build it. So we are going to say Docker build, no cache, because I want to show you the whole rebuild process. Normally when you build a Docker image, every one of those run lines actually builds a new layer on the image. And when you rebuild, you don't have to rebuild the lower layers unless they've changed. So I don't have to build this. It'll download it for me. And if this hasn't changed, it won't rebuild that part. It'll just rebuild each run line if it's needed. But I'm going to say no cache, rebuild the whole thing. Okay, so we are going to say, now this is where the SSH comes in. I'm going to say, because we're using that experimental feature that safely shares my SSH key at build time, I'm going to say, well, I want to use default credentials, and they're stored in Now, if you're familiar with SSH, you know that permissions on your keys are very particular, and if they're too broad, SSH will just refuse to use them. And that is the default state when you do this build process, I actually had to go and disable inherited permissions on the folder that contains my SSH. And in this case, I'm using Windows 10's a new support for OpenSSH. So if you don't know, Windows 10 now uses OpenSSH natively. And so it's got its own .ssh directory. I had to disable inheritance, or else the Docker version of SSH thought my permissions were too broad, which isn't true. This fixes that. So I've told it, hey, I want to pass my SSH key in safely at build time. Now I need to give it a name. I'm going to tag it. I'm just going to call the image dmarc. And then I'd say, what do I want to build? Well, I want to build the Dockerfile in the current directory. So now it's going to go, and you see it's fetching everything to build that Python 3. Now it's doing the apt update, and it's saying, oh, I got a whole bunch of packages that I have to update. Now it's installing the dmarc program, which itself needs a whole bunch of Python dependencies. It finished that. Now it's cloning my GitHub repository using my SSH key that was passed in, and then it finished, and it had no errors. And now, if I say Docker image list dmarc, here you see I've just finished creating it 12 seconds ago. It's on Docker standards. This is really, really big. It's almost a gigabyte. Generally speaking, you try to keep your Docker images much, much leaner. This is another reason. If you're watching this, it's because you're probably interested in some of the things I'm learning, and it's because you're like, hey, if Michael can learn that, I can learn that. And that's true. One of the main reasons I got excited about doing experiments with Docker is because I build a lot of adversary simulation environments in VMware, and with say 20 hosts, 50 hosts, lots of virtual networking. And I started, and they always take a lot of RAM and a lot of disk IO. And Docker, I think I could get 50 hosts in an adversary simulation in just a fraction of that. I could probably run it on my super powerful laptop or something with no problem. So I've got this image. Now I need to run it. And what I need to do, let's go back just for a moment and take a look at what my script does. So it's going to take that domains file and it's going to parse it. And if we don't already have JSON formatted output for each domain in the domain list, it's going to run this and it's going to save it. And it's going to save it to a directory called data. Now remember, this is happening in the Docker container, which is a Linux machine. And so it's going to save all the output to this thing called data. Now here's what I want. One of two things would be nice. Let's start with number one. When this runs, I just want it to save it to my local hard drive. It's a Docker container running on my Windows machine. I'd like it to save it on my Windows machine. Well, that means when I run Docker, I need to tell it to share a volume. And I do that with this -v switch. And I'm going to say, and this is, you wouldn't do this in practice. I'm like going to share. Never ever trust someone else's Docker container. And I wouldn't share my whole C home directory to a Docker container I didn't build myself. And even in this case, I'm building it on someone else's. I don't know what's in that Docker container, that Python 3 one. This is not a good practice. And I'm going to say mount this Windows directory, but inside the Linux container, call it /data. And then I just say which image I want to run. Well, the one I just built called dmarc. And now, if it did its job, it should have saved that data in a folder. Now let me go check to see if it is where I think it is. Just doing this off screen, and then I'll bring it on screen. Oh, and there it is. So this is the thing I mounted is /data, and my script saves its output there. And there's the JSON file that my script created. All right, one line, and I can run this thing that got all of my script from the GitHub thing. Now, if I want to update this script, because as I said at the beginning, I actually lost the fancy version of the script that I was using before. Now I have to recreate it. Well, now if I want to update the script, I'm not doing much. All I'm going to do is edit this thing, paste in my new code into my GitHub repository. And when I'm done, I rerun the Docker build, it reclones it, updates it, and then I run the script. Piece of cake. For this particular project, it's trivial. I don't need to go to all this length. I could do it other ways, but I'm actually trying to update this. I have a series of projects that are for doing cyber intelligence gathering. And what I really want to do is have a series of Docker containers that will go off, gather a whole bunch of intelligence, and then take that data and maybe put it into Elasticsearch, or put it into another pipeline, feed it into Logstash for enrichment of data, and then feed it into Elasticsearch. And so as I'm tweaking these things, anytime I want to run them, I just want to get the thing out of GitHub and then have it run. Now let me address one final little bit. I actually would prefer not to save it to my hard drive. And that's because I have a few environments where I can run the Docker containers, and it's not always going to be, I don't always want to run it on this machine. If I run it on my desktop, I don't want that thing running for 3 weeks. I want to turn it off at night. So I have another machine, a Linux network attached storage system that can run Docker containers. I have a DigitalOcean account where I could run Docker container. What I'd really like to do is have that script run, and when it's done, check the contents back into GitHub. And this is where I have a bit of a challenge. And if you're watching this either now or later after it's recorded and you have some suggestions, I'd love to see them. I've been looking at a lot of other people's suggestions, and they're developers and they don't always realize the threat surface they're creating when they use a container that authenticates to their account. I'm going to bring up my script again. So here's one way I could do it. I could say, when I build my Docker image, let's assume that there is a directory called /data, and inside of it is an RSA private key. And whenever any commands in this Docker container use git, they're going to use this identity for git. Now, this would allow me to take data that's in this container and push it back to my GitHub project. If this were a VM, that's exactly what I would do. I would have a VM with my development environment, all my scripts, and when I was done, and this gather script is run on 1 million domains, I'd push all the data back into my private repository, and that'd be cool because then I could have other scripts in that repository that analyze the data. The question is, how do you get this into the container securely? I've already said I'm not doing this. I am not adding the private key to this container as a permanent part of the container. I could. I could also use, I've seen other developers use OAuth tokens. They say, oh, you know what? Just go to GitHub, register a new application, get an OAuth token, and put it in here. And that says you're trusting the Docker container and anyone who runs a copy of the Docker container to access that GitHub repository. And you can put limits on it. So you could minimize the threat surface, but I'm not doing that. If I understood more, maybe, but my gut's telling me that's not the way to do it. In fact, it's maybe worse than this. So what if, when I run the container, I expose something as data that's from the runtime environment that Docker's running on, just like I exposed my C users Michael directory. I could expose that at runtime and let the container access this key. And then this script would have access to this environment. And because at runtime I said mount this, it would have access to the key, even though it's not copied into the image. So it would be up to me to make sure that whenever I run the container, it's secure and that this key is held securely. I think that's a little better, but I really don't like it. So right now when I'm working on this, I'm not using this yet. I'm not going to let it use that. I'm just going to do this, and I'm saving the data locally. There's got to be a way, and as it stands, you cannot use this secret sharing mechanism that's part of the experimental build kit. That's only for build time for the container. It's not for run time. It would be kind of interesting if you could pass this in. Now, I've seen some other people that take the SSH key agent and then they pass that in, and it works great on Linux because that's a socket, and you can actually feed the socket in as a file at runtime mounted. But in Windows, it's a named pipe. If you're not a developer, you probably know what those are. It's just a complication. And that's pretty much what I wanted to share about my journey of learning the new thing in Git. So I started off with overcomplicating how I wanted to handle a simple project. Use that as an excuse to learn more about Docker. And I really succeeded in that. I learned more about the build process. I learned about this cool secret sharing thing, which I think is so much better when I see the way other developers are handling getting SSH. And there's a lot of people that are starting to clone GitHub repositories at build time, but not everyone's using this mechanism. And then I ran into a problem that I haven't been able to solve yet, highlighting that the world of containers is awesome, but as a threat analyst, oh man, there's a lot of juicy work to be done because people are making mistakes and increasing their threat surface while creating new architectures for development. So, Mauro, my one audience member, any questions? Okay. Well, I will end this session, and the next one won't be next Tuesday. It's going to be the Tuesday after. I think I'm going to switch to doing these every alternate Tuesday. Gives me a chance to learn a little bit more. But I'm going to keep doing these, and I hope you keep watching. All right. I am Michael McDonnell. I am the cybersecurity librarian. Thank you.